Hi everyone. We are now back from lunch with Axel from Fortinet. She will have a presentation about infecting Internet of Things. Thank you.
Hi. So, well, thanks for joining me, and sorry for the delay. We were having kind of a few problems with displays, but, well, we'll try and get around those. So I'm going to talk this afternoon about Internet of Things, and I've brought, well, as a matter of fact, we'll be talking about smart glasses. Those are there, and also a smartwatch. I didn't bring that one though, but hopefully I hope you'll enjoy it. Introduction, I'm very bad at displays. The other thing, well, I've been working now for like over 8 years at Fortinet. They're both malware analysts and a security researcher, so I'm working on advanced signatures for smartphones and smart objects. And this time the talk is very much about, of course, smart objects there. As you'll probably notice, if you want to speak to me afterwards, I'm afraid I don't know more than like 2 words of Romanian, so it will be either French or English, or hexadecimal as a matter of fact, but well, French or English will probably do better. And, well, we will go straight into the demonstrations, actually, because I'm sure you've been seeing quite a couple of slides. So, this is where it's going to be tricky, because I'm going to have to do this blindly. But well, I've got those glasses. Those glasses are manufactured by Recon Instruments. At some point, they are tied with Intel, because when I reported a vulnerability to them, well, Intel actually replied. And, well, you've got a display there. You've got a trackpad here on the side, a button, and the batteries are on the other side there. Okay, so, and make capture. And this time it appears, sorry. Okay, so that's what I have here on my screen. Now let me show you a little bit more. You can have some applications. So I'm scrolling. So for instance, it's meant for cycling and running. And I got it here. And there you go, okay? Now, you have some other applications there that you can install. I, for instance, have a camera. I'll show you a little bit what you look like. Camera. There it is, and Control W. Closed it. Smile. And there it is. Okay, so that's the quality of the image there. Okay, so that's basically what we have here. And one of the things that I did is, well, kind of work on those smart glasses and manage to understand a little bit more how they are working. And one of the things I'm going to try and show you is a ransomware on those smart glasses there for a minute. Right. So I'll close this. This was just like an overview of the glasses, and I'm going to go back in the previous directory. CD demo toast. Yeah. So what happens, and it's going to be a little bit difficult to show you unless I manage to have Where's my pointer? It's here. Okay, difficult. Okay. Well, Imogen, on the other hand, that what you receive is one day an email where it tells you, okay, this is an email from security updates of recon instruments, and there is a security update for your glasses. Please install this or that package, and it provides you the package to update to your glasses. Now, you are security researchers, so you know obviously that emails can be easily forged. So you might be, of course, a little bit suspicious, right? But actually, if you are like 99% of the population, or just actually a few security researchers even a few months ago before Mirai was out in the net, you probably don't believe that smart glasses can get infected whatsoever, right? So there are quite good chances that you will just install that package there and put them on the glasses as is required without actually being suspicious there. And that's what I'm going to do. And so I'm going, Imogen, so Imogen, you saw a very nice screen of that email with the package, and now I downloaded the package, and now I'm going to install it. So it's fortunate I didn't have too long commands. There I am installing it, and now, well, basically the ransomware is installed, and we just need the attacker to trigger it one way or another, and that's what we're gonna do. We're gonna trigger it. So make ransom 1. Well, it worked on my screen, and yes, I get it. I'll show you what I get. That's what I get. So right there in the middle of my display, the display is there. I get a message. I'm sorry, it's a bit small. I can't make it very much bigger, just for that. But it says pay $5 to get rid of this stupid message, right? It's certainly very stupid, right? But as the glasses cost like $500, that's something like over 2,000 lei, I think. Well, you really want to use them, and you're quite likely to say, well, okay, I'll click and pay the ransom because I need to use them. If you're not a techie, you don't know how to get rid of that message. So you're kind of a little bit hopeless there, and if you want to report this to anybody, well, I don't know how it works here in Romania, but if I went in France with my smart glasses to a police station and tell them, well, I've got a ransomware on my glasses, I'm sure they'd quite laugh or tell me, well, we're sorry, lady, but like, you're hopeless, we can't do anything for you, right? So we have, in a few minutes, infected those glasses with the stupid message, and I can change the message with whatever you'd like there, and to create a ransomware. It's as simple as that. So I'm gonna try and shift back to the slides. Yeah, we'll see that in the code. I'll explain how I'm doing it. But yeah, it's in my demonstration, it lasts like for 5 minutes or something like that, but I can make it infinite. I didn't want to make it infinite because it would be bothering me for the rest of the demonstration. There we go. So yeah, that's how it works. So to understand how it has been implemented, basically those glasses, well, they have plenty of sensors, as you can see. They've got a temperature sensor, they've got a pressure sensor, they've got also what the recon instrument calls a free fall sensor, so it just senses that you're kind of dropping. That's kind of probably useful for sports. And all of this is used by Android, and Recon Instruments has built their, what they call their Recon OS. It's very much like rather a large SDK on top of Android. And they provide some system applications there with, for instance, the heading. Are you bearing north? Are you going south? Where those kind of things. You've seen the application for the camera. You've got also some things for GPS. Well, you've got quite a couple of different applications. And on top of their SDK, they've also opened it to third-party developers. So you can have a legitimate third-party developer developing an app to, I don't know, get the weather forecast on your glasses so that you know if it's gonna rain while you're running or not, something like that, for instance. And that's exactly what I did. So actually, I didn't even really need the Recon SDK. I just built an Android application and made direct calls to the Android APIs, the standard APIs there, right? And that's the way it works for this one. So the code, the source code, well, it's pretty simple. The idea behind it is just to use, well, if you have been doing some development on Android, it's using the Toast API, that's all basically. So we get the message that of the ransom that we want to display, and then we toast it. And then if we want the message to stay quite long right in the middle of the head, what we do is we loop several times, and we can make, of course, an infinite loop. So that was actually your question there. It's very, very simple. I think the whole Android application, for the source code, it's like 30 lines of code, no longer than that. So it's not difficult to write, but that's also what makes it more scary, right? So I said I could control with that application any ransom message that we would be having. For instance, just imagine that we have something else that, you know, that $5 stupid message. It tells you we recorded your day's activity and pay this amount if you don't want them to be published. Now, this is kind of a little bit embarrassing because those glasses, as I have shown, they do have a camera, right? So it's feasible that somebody did actually trigger that and record them. I'm doing the screenshots actually as the same way. I'm triggering the camera, taking snapshots, and showing them to you, what is displayed on my screen. So it's technically feasible. So depending on the situation, you might not want somebody to publish, of course, a video of yourself, whatever, okay? So those are situations where the ransom can work well. Some other situations is, besides smart glasses, is if you've got a critical smart object. So thinking of, I don't know, medical Internet of Things. Well, if you've got a blood pressure connected object and it tells you, well, this is a fake screen there, but telling you, well, pay us $10 or whatever amount, or you're not getting your current blood pressure. Well, as it's kind of a critical condition, you might need it for your health, you're likely to pay. Another one, this time it's insulin pumps, same thing. If the display has been hacked and somebody displays a ransom there and tells you, well, you know, no way, you're not getting your insulin rate at this moment unless you pay me. Well, I'm pretty sure that quite a few people would be paying there as well. And this isn't that much like future. A month ago, there were several vulnerabilities which were found on one-touch ping insulin pumps. So there are vulnerabilities out there. So getting them infected, it's like the next step. Other thing that you wouldn't like to see ransomed, your cars. So it's really getting like a complex connected car. But if in the morning you wake up, and you're, I don't know, you want to drive to work and your car tells you, no way, pay the ransom $450, or you're not going to work or something like that. Well, if you're in a hurry, knowing that if you tow your car and go to the garage, it's probably going to cost you pretty much as well, and you might not get it fixed. What are you going to choose? Okay? So those are just examples, but they are examples for the best business cases for ransomware. And when there is a good business case, well, of course, it interests the attackers, and then that means that, unfortunately, we'll see malware on that. And the best business case comes either when we've got, like, a device which costs pretty much. So a car, that's expensive. Smart glasses, well, it's, of course, much less expensive, but it's still expensive. Those are devices that you don't want to see hacked or not to be able to use any longer. And the other factor is their criticality. So we saw for the insulin pumps, some medical things. I showed there as well, smart TV. Well, I entirely agree that televisions are not like life critical, but still in plenty of families, if you tell the kids, oh, well, sorry, the TV's being hacked and ransomed, you're having no more TV for the next year, I'm sure that is going to be quite a problem, right? So, I hopefully made my case for ransomware. We are now going to see, because there's not only, unfortunately, ransomware there in the picture, we also have Trojans. I told you that those glasses there, well, they had Android on them. I don't know if you're aware of that, but we have currently 500 new Android malware per day. Every day, every single day, it's 500 new malware which are out. So, of course, the immediate question there is, well, okay, can these run on the smart glasses, right? So, of course, the answer is, well, yes, in theory, because it's Android, and my phone as well is Android, so normally it should be able to work. In practice, we have to check this, because it's not exactly the same thing all the time. The smart glasses, they don't have, for instance, any GSM access, so that changes a couple of things. The internet access, they do have Wi-Fi, but it's a little bit more difficult to get connected. So there are kind of a couple of few things you need to check to see that if really the malware is working. So that was the idea. I told myself, okay, now I've got to try and see if a so-called Android malware can work directly on the smart glasses. And that's what I did. I happened to have written, like 2 years ago at Black Hat, a proof of concept malware for Android 4.4.2. And I told myself, okay, well, I'm going to try that one and try them on the glasses. So this proof of concept malware, what is it doing? Well, the idea is that we are hiding an entire Android application in an image, right? What you see there is just the image of, well, it's meant to be the drawing of Anakin Skywalker in episode 2 or something like that, okay? Bear with me for the drawing. So you see just a display of this image, and we are able, by some trick, to decrypt that image into a valid application. That is quite a useful scenario for an attacker, because as the Android application in the end is kind of, well, at the beginning it's encrypted. Of course, for a malware analyst, well, it's difficult to analyze it. You can't see what's in there. You can't see that it's doing something malicious. So it's more difficult kind of to detect there. The trick behind this, to get this working, to get an image really turned into an Android package, is of the manipulation of the file format. PNGs, if you get down into the specifications of PNGs, they are divided into chunks, right? So what we do is we do in the file put at some point a valid PNG chunk with the image of Anakin Skywalker. But before that, we put some other chunks, and we put another chunk, which is a dummy chunk that PNG viewers do not know. And that PNG chunk is actually the encrypted Android application. So that when we decrypt it with the right key, well, the chunk which corresponds to the ciphertext gets decrypted to a valid Android application. And the part with the PNG, well, it will be decrypted also to something, but to something totally useless, which ends up at the end of the Android package and doesn't impact the Android application. So that's how we can have like a valid image turn into a hidden Android application. So what we do is that we install this application, and that's basically what you see, a screenshot of what you see on the glasses. It gives you a new application on the smart glasses, right? Then what we'll do is basically we will click on that image there. Sorry, I'm going a little bit too fast. Yeah, what I forgot to mention, and I think otherwise you'll not be understanding. So I created an Android application around that image. So I have an Android application which is displaying the image of Anakin Skywalker. And whenever we click on the image, that will trigger the decryption and install the hidden application, which is the malicious payload. Right? So let's go back. We install it. We get the application. We see the image of Anakin Skywalker. We click, and immediately it triggers, it decrypts into a valid application, which tries to get installed. And you get the message, would you like to install this application there? So this is a proof of concept. So this could have been hidden. My point here was only to demonstrate that I could turn a valid image into a valid Android application, but not to hide the valid application in that case. But it's possible. It's already been done. Plenty of researchers know how to do that. You use basically classes such as dex class loader, and you can hide the installation of a new application. And we install a new hidden application. So we have, and that's like kind of the joke of it, we have Anakin Skywalker turning into Darth Vader, right? And this application is exactly the same that I had on Android. So that exact application I had on Android is working directly on the smart glasses without any modifications. So, I would like to try and show it to you live. And that, so I'm gonna go to the right directory. You're not seeing anything yet, but you will, hopefully. So I think I'm in demo toast. I'll go into the other directory, demo, I think it's demo advanced, right? There we go. I'm sorry about this, but I don't have it on my screen, so it's pretty difficult to type blindly. So I'm gonna install that application. So the proof of concept, there it goes. So now it's on the glasses. That you surely want to see something. So I'm gonna browse and show you some screenshots, live screenshots. So there it is. Make capture. And it gets here. Okay, so that's the screenshot I told you about. Let's break that one. Now I go into the application, make capture, and you see the normal standard application with the image of Anakin. And now I just have to click here, okay? I just click there. Make capture. And that's what you get, okay? The screen of an installation of an application. And, well, of course, if you're kind of a normal person, you're not going to install it, but, well, we're not here for normal person, for security researchers, but for the others. So I'll click there, make install. It installs, make capture. There it goes. I can now open it. Click there. And so make capture. And you get the image of Darth Vader, right? And you do have two applications which are now installed. I'll show you both applications. So that's where we see visually both applications. Make capture. Okay, so you now see that's Darth Vader application, and on the left-hand side you can see the other one. We can also see it another way. So ADB shell PM list packages grep POC. So this is a command to connect to the smart glasses and see all the applications which have the name POC inside. That's the name, of the name I've given them. And you see that now we have two of them. We have the original application, which is called Encrypt, and the second one, which is called Payload. And at the beginning, of course, we only had the first one, Encrypt, only one of those. And as a matter of fact, ADB shell, you might just like once in your life to see your shell on your smart glasses. So there we go. This is a shell on the smart glasses, ls. That's what we have there. We can, I don't know, we can go in data perhaps. Not sure that is allowed. It is. And we can list some of, no, we can't open that one. But we can go in the SD card, of course. We can get some system properties as well. That's get prop. Okay, so that's the cool cool work about that. You really have a shell on your smart glasses there. Okay, so that's about all for the demo. Now back to the slides. Yeah, I'm getting so good at that. Yeah, so now, that's about all with the smart glasses, but now I'm going to talk to you about the other one, the smartwatch. So I have been working this time on a Sony smartwatch. It's one which has been out like in 2013, but it's not that old yet. It is running a special real-time operating system called Micro C OS 2. Not very familiar with that system, and I guess it's not that well known. But you've got also on the smartwatch, you've got some sensors such as the light sensor, an accelerometer, and you've got, well, some cool stuff there. So I thought, well, okay, I've showed you a ransomware, I've showed you Trojan on the smart glasses. Now the other thing which is popular, let's say, is SMS dialers. So if you remember, in the old days we had dialers on modem, then we had SMS dialers on smartphones. Well, here they come on connected objects, unfortunately, right? So for that one, I have a video. Let's try and show you the video. F1, and hopefully that will start it, yes. Okay, so this is just showing you the code, and now what I have done is I wrote a smart extension, that's the way it's called in Sony's terminology, that will be malicious. Of course, it's a proof of concept. I'm not doing a real malware out there, but that proof of concept malware is going to send SMS automatically to a smartphone in my lab. If it were an attacker, of course, it wouldn't be sending it to a smartphone in my lab, but to, for instance, a premium phone number, and that would be just the perfect way to monetize the attack there. So I'm installing something on the smartwatch, and as it is paired with the smartphone, you will see it both now on the smartphone and on the smartwatch. So that's just like an about screen there showing what this demo is doing. And then notice on the smartwatch, we'll shift to the smartwatch, the bottom right extension, that is the one I have just installed. Bottom right. There it is, bottom right, that one. So I launch it. And, well, now this is pretty obvious. It is sending an SMS to the smartphone just next to it, right? But now what is a little bit more tricky is that it works even if the smartwatch is not lit. And it will also send SMS if the smartwatch is not lit. So this means that once this kind of malicious extension is installed on your smartwatch, and you've opened it once, well, whenever you're gonna just merely touch the screen of your smartwatch, it's gonna send an SMS. And you don't have any notification. It's not like vibrating or giving you any notification on the smartwatch. It will just be sending it out there. And of course, well, it can be monetized at the other end. So that was the demo. Let's go back to the slides. There. So how it works? Well, what happens is that actually in Sony's architecture, so this is really very specific to this smartwatch, the smartwatch acts really like a remote display of the smartphone. It won't work if you don't have the smartphone. There are some other smartwatches out there, like the Samsung Gear S2, I think, or G2, mixed up with the numbers, and those already have directly a GSM connection. This is not the case with that one. That one is having everything being relayed to the smartphone. So when you are kind of apparently installing a smartwatch extension, actually, you are not. You are installing an application on the smartphone. The smartphone is doing like nearly all the job, and it is just sending a few messages to the smartwatch to tell it, display this, display that, display a pixel at this part there or not. That's only exactly what it is doing. And then for the code to work, basically, well, if you follow the way that some extensions need to be written. If we want our SMS dialer to react as soon as we touch the screen of the smartwatch, well, then we have to write an extension which inherits from a class which is called control extension. That's one part of the trick. Second part of the trick, we want an action to happen, sending an SMS when we touch the screen. So this is really quite simple then. At this point, we implement a listener for the button, and what we do there is we create a button which takes all the screen of the smartwatch, so that you can't click just next to it, you can't miss it, right? And when you click that button, it will call the listener, and in the listener, we have it send an SMS. That's the basics of the SMS Trojan. And then for the part where we want it to work as well when the smartwatch is not working, well, it's not, lit. Well, we have to use what is called the low power API of Sony, and this is very simple also. We just have basically to implement a function which is called supports low power mode, and say yes, we want this, and then the application will work also when the screen is not lit. And that's it. So that's an efficient dialer. Now, the other kind of malware that we can see, of course, is spyware, right? Spyware are especially interesting, I'd say, on connected objects because you've got plenty of sensors. On those, you've got an accelerometer, you've got a gyroscope, you've got a compass, you've got a light sensor, you've got so many sensors, you've got a camera, so you can get plenty of information from there. And that's interesting. But it's not the only case. Think of a sports tracker, for instance. Well, you also have plenty of information of how much you are running. Sometimes you also have the location of where you are. You've got plenty of information there, which are just perfect for spyware. So that was exactly what Dilbert thought as well. So here he's saying, like, it's the mom attack. His mom is spying onto him with his Fitbit tracker. I found that quite amusing, right? So the business case for a spyware, well, it is to have plenty of onboard sensors. And also the other part is that when it's a wearable, well, you're wearing it, so you are walking with it, you are living with it, you have it everywhere, and that's also a very good case for spyware, unfortunately. Right, so far I have been demonstrating ransomware on smart glasses, the advanced Trojans, the SMS dialer as well. So those are malware that we can install on connected objects, and you have seen it's not that complicated. As a matter of fact, there are already some malware on IoT. And I'm sure that you have heard most certainly of that Mirai botnet a few weeks ago, who did plenty of denial of service attacks on Krebs, on security websites, on also on DIN, the DNS provider, also on an OVH, French internet provider. So this one got a lot of media and attention because they managed, as a matter of fact, to draw like 100,000 bots to drive an infected IoT to actually attack another given target. And it's an another exact illustration of what can happen to connected objects. In the case of Mirai, what got infected was cameras, DVRs, digital video recorders. The attackers did not really care about the webcams or the DVRs. What they wanted was to attack this or that website, right? So that's another reason to hack those Internet of Things, as a matter of fact. As you can see, there are quite actually a couple of other malware out there. Perhaps you haven't heard of them. Many of them are targeting or trying to do as a motivation denial of service attacks, but not only. We had some kind of strange stuff that we saw, Linux Moose. This one is infecting plenty of connected objects to have them like this or that on social networks. That's kind of like an amusing stuff. More longer ago, we also had Darlos, and Darlos was infecting ADSL routers. And what was interesting there, what was kind of special to it, is that it was using them to mine cryptocurrencies. It's no longer done now because I believe that you need much more power to mine cryptocurrencies. But at that time, it was maybe they managed to mine a few bitcoins that way. The future. Some things that we haven't seen yet, but that I think we will be seeing sooner or later, is propagation of worms using wearables. So the scenario there is that what happens is that one day you've got an attacker who infects your toothbrush, your smart glasses, your smartwatch, whatever you have, but a wearable, okay? And manage to infect it. And let's say it's your toothbrush. Well, you are going, I don't know, to DefCamp, right? You go to the hotel. You don't actually know that your toothbrush is infected, but, well, it is. And while you come over here, well, you infect all the other people in the hotel with your connected toothbrush. And that propagates, your toothbrush propagates the virus to, I don't know, another laptop or to some more connected devices. This is not yet done, but it has happened in the past with smartphones, and it has happened, of course, in the past with computers, and history tends to repeat, so it unfortunately probably will also happen with connected objects. And keep in mind that we have already like 2 billion of connected objects out there. So if we have only part of those which are wearable, we will be kind of propagating more than the flu everywhere. Like it will be also computer viruses. Last thing, also, what we have been seeing so far is very much the infection of complex Internet of Things, like webcams, routers, digital video recorders. Those are really kind of devices which have like a real embedded Linux out there. They're quite heavy. But what I think is possible is that we are going to see malware on anything, and even on very small or simple devices with simple microcontrollers or things like that. So we can have an infected toothbrush, we can have an infected connected basketball. Yeah, those exist, by the way. We can have an infected connected doll, an infected sports tracker. As soon as you have a firmware on them, well, the firmware can be upgraded perhaps, and perhaps also infected, right? So that's a possibility. And to this, we are getting to the end of my presentation. I've gathered, well, my slides will be available, of course. I've gathered quite a couple of references if you want to dig in a little bit more there. And that's all. I thank you for your attention. And if you have questions, but I'm not sure there's time.